beautiful people, welcome back to my channel. My name is Harodi, the Path Principal. I'm back again with another video. I know that with the previous video, when I opened it up, I spoke that we're gonna do an LJ review, but after doing the waistcoat rules, I saw that the video was going to be too long, so I decided to do them separately. So now basically we are going to do the LJ review. So this is how our LJ graph this is how our LJ graph is going to look like. So what I said at the beginning when I started with quality control, I spoke about that quality control it's monitored, not that it can be, it definitely is monitored on daily basis. And then as well, depending on the lab's code protocol, they'll either do LJ reviews every week or every 2 weeks or every month. But on a daily basis, as you are running your quality control, you also do check how your control sample is performing. So on what we usually look for on daily basis, we'll be looking for outliers. So basically what outliers are, it's when like the point is outside. So depending on the rules of the laboratory. So usually waistcoat uses a 3SD range. So now we're gonna do it following that. So it means in this case, an outlier, it will be a point that is outside a 3SD range. So let's say we have a point here. Which is outside the minus 3SD. So basically it is outside the 3SD range. So we will indicate this that it is an outlier. So this we see it on daily basis as we run QC samples. And as soon as we see that there's an outlier, we'll try to troubleshoot it so that the control value can be within the range that has been set on that specific analyte. So what can cause these outliers? An outlier usually can also be caused by maybe it's a random error, probably the instrument didn't pipette correctly with that one, or maybe the preparation at that point. Because as well, when you see an outlier, you will look at you will rerun your sample, and then after rerunning it, and then you see it still give the same result, you can start questioning. Probably it might be how you prepared it, so you would rather get a fresh one. And then if it corrects after you prepared a fresh one, it might be that probably when you prepared that one, or when you prepared the other one, the first one, something happened with the pipette, or the volume was not precise as it is, or the instrument was not putting in the correct volume of the reagent. And so it can be a lot of things, but most of the time it can just be a random error. So that is why we will check this on daily basis after you run your QC samples, and then you will troubleshoot it. And then another thing that we'll usually look at when you do an LJ review, we will look at a trend. So what a trend is, basically it is a gradual loss of reliability. So it is gradual. So you find that now your points, it's either they are going downwards in the same direction, or they are going upwards. So that's why we can either have a positive trend and a negative trend. So if I can show it in a form of a graph, it's when you have points like this. And basically it has to be 7 points. So it's a gradual loss of reliability. So this is a trend, and this is the outlier. So what can cause a trend? So a trend, it can be caused by maybe the stability of the reagent. If your reagent has been in your machine for quite some time now, and then it's getting old, then you will see that with the decrease of the values, or it can also be due to maybe a light, your halogen lamp needs some replacement, maybe it's been there for some time, or the QC material that you're using as well, we will question its stability, and as well we'll also question your calibration status. Maybe the this analyte, you haven't calibrated it recently, and then now it starts to either go, your QC sample starts to either go down or they go up. So basically that is the trend. So whoever who the QC officer, whoever is reviewing the graph, they will look, when they see this, they will go and check on all of those things. So if it's a bulb, or if it's a maintenance that was never done, or a service that was never performed on that instrument, then that will need to be done quickly. And then if there is a reagent stability is questioned, that means we have to put a new reagent. If it's the stability of the QC, we have to use a new QC, and so on. So that's how they'll investigate this. And another thing that they will look at shifts as well. So shifts, it's when you have, let's say we're having a trend here. So from this point on day 6, and then probably you calibrate because you saw this trend, and then you were querying a probably calibration status, and you decide to calibrate your cal stability. So as you calibrate now, after calibrating, when you run now your QC sample again, then this value, then now your values, they shift to the other side. So it's a movement from one side of the mean to the other side of the mean. So basically we'll define this as a sudden change or an abrupt change of points, whereby they move from one side of the mean to the other side of the mean. But this, we don't only identify it by one point, you have to have 4 points basically to definitely say that I have a shift. So like I said, a shift can be caused by, after you have calibrated, or if you have changed, you've just changed the lamp now, there can be a shift, or if there's a new lot number of your QC, or a new lot number of the reagent, or a new lot number of the cal, can also cause a shift. And then the next thing that we would look at is a bias. So the bias is the same as that 10x. So a bias is when you have 10 consecutive points on one side of the mean. Like that, for example. So once you see consecutive points on one side of the mean, then you will start thinking of a bias. And then a bias, you can either have a positive bias or a negative bias. So a negative bias is like this example that we have here, whereby your points are on the negative side of the graph. And then a positive bias, it will be on the positive side of the graph. So with this bias, usually what they will do is that you will check as well, as soon as you see it, now you're gonna check whether does it fall within a 1SD or is it outside the 1SD. So if it's within the 1SD, you do not have to troubleshoot it because there is no clinical significance. But once it's outside the 1SD, then now it becomes a problem. It becomes a rejection, whereby you need to try to do something about it. And what can cause a bias? A bias, it can be caused by probably a reagent lot that is changed, calibration status, the calibrator lot, or the integrity of the calibrator. If I remember a story about the integrity of the calibrator, there was once in one laboratory where I was working in, insulin constantly gave us a negative bias. So now this issue was handed over to the application specialist from the supplier. So when the application specialist came in, what he found out is that we were storing our insulin calibrator in the fridge instead of that it's supposed to be in the freezer. So it means every time the stability of the calibrator was compromised already. So every time when we were calibrating using a calibrator that has been compromised, and that caused us to our points to always being on the negative bias. And according to Westgard, if we have that a 10x, like a 10x rule, if you can still remember from the Westgard rules, if we have that, it's a rejection, especially if it's outside the 2SD point. So basically that's what will be done during an LJ review, and that's what they'll be looking at. So I've just tried to summarize things as much as possible, but there is more to it. Always make sure that as well you follow your own laboratory protocols into troubleshooting this. Thank you so much for joining me and listening to this. From me to you, up until next time, toodles.